Hello guys, how are you doing? Let me trust you're doing good. Today we are going to talk about no power motherboard. So this is a study course whereby we shall discuss all the factors, all the components which are responsible for power supply inside the laptop motherboard. When you receive a laptop with no power, which components are you supposed to check? What are the things are you supposed to consider? Yes, here with me, I have several of the motherboards which we are going to use them to discuss whatever we are going to discuss today. There's a video which I made not long ago about the input power supply. I believe you can revisit that video, then you can check for yourself because in that video I also drew a lot of diagrams which explain the input circuit. Yes, because in a laptop motherboard, the power enters into the motherboard in stages or in phases. That's what's called phase one, power supply. Then we have phase two. That is in phase two we're gonna have the step down voltages. Now, since we had already discussed about the input components, the input line, the input circuit, today I am just going directly to mention those components and to show you the locations of those components. You know, it is not always direct. It is not always direct to locate those components. I know in that diagram, we drew a power port, then we drew an inductor, we drew first MOSFET, second MOSFET, power resistor, charging IC. Now, in the real sense, or in the real time, when you have a motherboard, they don't always place those components near to each other. Sometimes you might find a power port. Let's say this is the power port. Then in this power port, you could find the inductor or the fuse at this other side, maybe at a location somewhere here. Then the second MOSFET, you might find it somewhere there, or that is the first MOSFET, you might find it here. Second MOSFET the other way around, and then I believe that design is so crazy. Yes, it might not be in that way. Maybe I exaggerated a little bit, but bottom line, I'm trying to say that that those circuits or those components they are not placed together. Yes, you might find the power port here, then the first fuse, first MOSFET, second MOSFET here, and then you find the current sense resistor in another location, maybe somewhere here. You getting? But some other motherboards, you find those components are very simple. They are just placed just near to each other. For example, this one, I have the power port here. So this is the USB for Lenovo. This power port, you could see that the positive terminals are connecting to this component, which is the fuse. This is the first, this is the power fuse one, which receives power from the positive terminal of the adapter. From this power fuse, this white component, I believe you can see that white component, the power is released to the first MOSFET. This is the first MOSFET, and then near to it, you have the second MOSFET, and then after the second MOSFET, you have the current sense resistor. Then from this current sense resistor now, the power is sent into the motherboard. But as you can see, with this motherboard, you can't see the charging IC anywhere near here. You see? And the charging IC for this one, you only locate an IC which is labeled BQ. As you can see here. Now, can you see the location? We have the first and second MOSFET here. We have the, not where, yeah. This is the port, fuse, first MOSFET, second MOSFET, and then current sense resistor. Then from here, from this area, you have the charging IC there, where you will have the MOSFET to generate the main power line and the charging MOSFET. You see now how it doesn't make sense. I am going to show you another illustrations whereby we have those components far away from the power port. Here is another one. As you can see, this is another motherboard. And I believe these designers for Lenovo motherboards are crazy guys. Not crazy in bad way. They are crazy, I don't know, in good way or what. Because those technicians, we normally encounter a lot of difficulties understanding the design or the architecture of these motherboards for Lenovo. Can you see? This is the Lenovo motherboard. Still, I removed the power ports. I removed the ports here because I wanted it donated it to another laptop which needed them. So there was the two type C's here. These two type C's connects to this. We have the power fuse for another line here. Can you see this tiny? I believe you can see this tiny fuse. Then first MOSFET, second MOSFET, then after second MOSFET, you have an inductor. No, I don't know now why they put inductor here instead of current sense resistor. It should have been the current sense resistor. Or maybe they placed the current sense resistor in somewhere else. Let's ask for. So this is the inductor. Then can you follow this track? Let us see where this track is going. It went this way, and then you have spheres there. So these spheres, it shows that this line, it went to the back. So let's see what is at the back here. At the back, we have other spheres, and then you have the current sense resistor. So this is now the so they put an inductor after the second MOSFET, and then again they place a resistor somewhere at the back here. So you see how these people are crazy. So tell me, what was the purpose of putting these ones here? What was the purpose for putting these inductors here? Because you could have the direct line from MOSFET 1 then to this main line. Same case here to this main line, and then it should that power should have been received by this current sense resistor and then released where? To the this circuit where it should generate the main power line. And then from here we have the BQ. This BQ, this is an IC which controls the input line. It controls the power through this first and second MOSFET, and also it controls the power by switching this dual MOSFET. Yes, I have the two dual MOSFETs here, this one and the other one. Right? Now, let us see another one. So this one was for Lenovo. Here, I have another one here. This is HP. So the HP also, we have the power ports here. These are the power ports, the Type C ports. The two Type C ports, it means now you have the two lines. So the two Type C ports, it enters into the first and second MOSFET and then to current source resistor. The other port also send power to first and second MOSFET, the current source resistor. And then from here, the power is sent to the high side MOSFET. And then from the high side MOSFET, it is switched to this side where it connects to the low side and then here to the ground. And then it also connects that power to the inductor which generates the which regulates the power which has been created by this to be sent into the main power line. So this circuit also, so first, second MOSFET, and then high side MOSFET, low side, and then high side is controlled by the charging IC here at the back. So this charging IC, the other one for Lenovo's or BQs. Yes, this ICs for where is it? Yeah. If you can see the top of this IC is written BQ something. It has a number. So this is BQ 25700A. So this is BQ 25700A. I know you might not be able to see it clearly, but if you put the home drive, the number at the top of this IC is clearly visible. It is BQ 25700A. Even this one, even this other Lenovo, it also have the same BQ. Where is that BQ? Where did this say this? It is there. So this BQ also, it is also BQ 25700A. It is also the same. I don't know whether you can zoom from your side so that you can see clearly. Now, but here, this one for the HP, which uses the two type Cs, instead of having the BQ, they do have what's called the interseal. Yes, this is the interseal. And this interseal is interseal 9241H. No, this is 95. Interseal 9538H. We could be having other interseals like 9241H, 88758. So many numbers of those interseals. And if you want to replace the interseal, you need to locate the exact number. You can't just replace an interseal with an interseal from nowhere. If you want to replace, let's say, interseal 9241H, you need the same 9241H. Or if you can't get the same 9241H, maybe you can use 9241CH or 9241BH. But before you replace, first confirm whether it is equivalent for that. You can just Google. You will just Google the interseal 9241H equivalent. Then you will get the options of the interseals which you can use on behalf of the one which you want to replace. Now, this one also is 9538H. Now, as you can see, these motherboards, they are not the same. This one, this is a HP Lightbook, then that G what? This is 1030 G4. Yes, this is 1030 G4. And this one, this is 840. This is 840 G5. Now, as you can see, this is 1030, this is 840. But they do have the same charging IC, 9538. into C9538. So in case I want to replace this IC, I can also take this one and put there, or I can bring the other one here, and it will work perfectly. Why? Because they are the same chips. However, you cannot use 9538H with 9241H. Now, the reason why we are making this video, is that we want to understand what normally go wrong. Yes, before you say your laptop or your motherboard has no power, what's normally go wrong with your motherboard? So there are common components which normally fail. Yes, there are very common components which normally fail in the laptop motherboard, and those components will make your laptop to fail supply power into the system. The first of those components, obvious, we have the power port. And I believe you know. How do you know that the power port is faulty? By plugging in the power, or plugging in the adapter, which is the power, and then measure the first component, that is the either power inductor. As you can see here, we have an inductor there. If it is for Lenovo's, most Lenovo's, they are fond of using what? They are fond of using the power fuses. Yes, if it is Lenovo, you plug in the charger or the adapter, which is the power, and then you measure this fuse whether it has received the voltage. It should receive the voltage which is about 20 voltage, maybe 19 or 18 or 20. From there, you have also to measure whether you have the voltages at the output of MOSFET 1. That is the source of MOSFET 1. And then from there, you have also to measure whether you have the voltage. Once you have the voltages at the output, it must also go here, and then you need also to have the voltage at the output of MOSFET 2. Then from there, that voltage also needs to be sent through current sense resistor and then the motherboard. Now, when the voltage doesn't go beyond this circuit, maybe the first, that is the fuse, or first MOSFET, second MOSFET, or this current sense resistor, that motherboard will not have any power. Not unless the power supplied from the battery is able to reach the system. That is the only exception. If the power doesn't go beyond here, not unless the battery is able to supply power. So that you say that motherboard have power. But so long as you don't have any voltage going beyond this line, this is the input circuit. So this is the input circuit from the port, that is fuse or the inductor with the HPs and the dells. You could find them using the inductor here. First MOSFET, second MOSFET, current sense resistor, and the charging IC. So those are the components for the input power line. Yes, those components are the ones which are responsible for ensuring that the power enters into the motherboard. If it is HP, for example, let's see this older generation. So this is the older generation HP. We have the port here. I remove the port so that I can help another motherboard. We have the port here. We have the inductor. This is the inductor. First MOSFET, second MOSFET, current sense resistor, and the charging IC. So those components are the one which are responsible for ensuring the power entered from the port until it is applied to the main board, so that it can be stepped down by other components which are responsible for that. With this one, the input lines from the port, if you are using the blue pin, we have the inductor. Then from the inductor, you have the first MOSFET, the second MOSFET, and then current sense resistor. Then from the current sense resistor, it will also goes to first MOSFET of this circuit. There is also another MOSFET which also referred to as first MOSFET, because this one can qualify to be first MOSFET because in case you use the Type C, you see also you have a Type C. In case you decide to use Type C to power on this laptop, the power will start from here, from this MOSFET. Then after here, it is switched now by the charging IC, so that it is supplied to the low side MOSFET, then inductor, then they release to the high side MOSFET. Then the high side MOSFET is the one which also release power to this resistor, which now from here the voltage now is applied to the main motherboard. Now, as you can see also, below this resistor, there are some two lines coming from below this resistor, and it is going directly to this charging IC. It is going this way, it's coming to this charging IC. because these two lines are also responsible for checking the power coming in and checking the power going out of this resistor. And those communications is used to regulate the amount of current which is in relation to the motherboard. So the components which normally fail is the port, obvious, because in case you have an issue with the port, maybe you keep doing what twisting your charger, it will start breaking the port, or the port will start losing. There's something else I forgot to mention. Here we have a component here, this diode. This is a charging ID diode. These components need to be working fine so that it can identify the charger which you plug in, and then it can allow that voltage to be sent to the other line. It communicates the adapter to the charging IC so that the charging IC can allow that adapter which you use to charge or to power on the laptop. Then from there, another common issue which normally happens is the first MOSFET getting blown up. Maybe it is shorted. The first MOSFET normally get shorted. Yes. If it is shorted, it means the voltage coming in here, it cannot be switched because this MOSFET is dead. All these other motherboards, those things are very common. Yes, starting from the port, which is which happens when you keep twisting your adapter. Number two, this also it could also get burnt, this fuse, and then next this MOSFET also. So you need to measure. When you're measuring the voltage, you need to check whether it went here, and then you check the other side whether the voltage come out from here. If there is no voltage output, there are several things could be the issue. Now you need to know what do you consider. Let's say you have the voltage coming in, and then you don't have the voltage going out here. So your number one suspect, it will be the same MOSFET. That same component, it will be your number one suspect. Now, your number two suspect is to check the main power lane, whether it is shorted to the ground. Because some motherboards or some laptops can cut off power from MOSFET 1 when there is a short in the main power lane. And I believe you know how to test for a short in the main power lane. Put your meter into continuity mode, one probe to the ground, and then another probe to that line. That is the current source resistor or any input line of this circuit. Then, in case it shows the continuity between the ground and that line, it will mean that the main power is shorted. So you have now to remove that short so that the system will allow power to go past MOSFET 1. Number two, this MOSFET 2 also could be the problem because this MOSFET, if it is shorted, the same system will cut off power from MOSFET 1. And then number three is the what? The judging IC. The judging IC, in our case, is the BQ. This is the BQ. The BQ also could be the problem. If it is the other motherboard for the interseals, that interseal also could be the issue. Because if the interseal or if the BQ is having the problem, the power cannot be switched from MOSFET 1 to the other side, from input to the output, from here to the other side. Because these MOSFETs, they don't switch power by themselves. Yes, it relies on the charging ICs to control those MOSFETs. So the charging IC in this case, they do act like a pump. They do pump power. When it enters here, it receives the signal and then it gives the instruction for this MOSFET to switch that power. So in short, it pumps that power from this side to the other side. I believe you know how the MOSFETs works and the sides. The MOSFETs have the drain, source, and the gate. So the gate of a MOSFET is where there's a communication. That's the communication line between that MOSFET and what? And the controller of that MOSFET. That is, in our case, is the MOSFET and the charging IC. If you have a problem with that gate, it means there will be no communication between that MOSFET and the charging IC. Number two, the drain is not connected to the source. So meaning what? When the power enters into the drain or into the source, there must be something. Something must happen so that that voltage can move from the drain to the source or from the source to the drain, depending on the type of the MOSFET you're discussing or you're following. So meaning the charging IC must be functional for that MOSFET to switch power. So when you find that the MOSFET does not switch power from this side to the other side, just make sure you exhaust all the factors. Because you might replace that MOSFET and then still you find that it is not switching again. Keep on replacing them until you finish all of your MOSFETs. And then you end up saying, oh, it is not working. Eh? And maybe even there is something small. The issue is maybe a very small shorted capacitor. which is making that circuit not to switch power. Or you could be having the corrosion with this charging IC. Maybe this charging IC has a corrosion here, or one of these capacitors or these resistors are knocked out by the corrosion. Maybe they are corroded until it is floating on the surface of the motherboard. If a tiny component like a resistor is floating on the surface of the motherboard, it means that resistor or that capacitor is not functional. If it is these capacitors for signals, among the capacitors, there are capacitors which are responsible for signal transmissions. So if it is those tiny capacitors, it means there's some missing signals which should be moving out to this IC, or moving out of this IC or going into this IC, so that IC is able to do what? Is able to send the messages, able to communicate with, be able to communicate with the MOSFETs. Now, having discussed that, so same case, whatever is happening with the BQ, it also applies to the interseal. This interseal must receive communication. When the voltage reaches here, the communication through the gate is sent to the charging IC, this interseal now. And the interseal will give commands or instructions to switch that voltage entering here to the other side. Same case, when the voltage reaches here, it enters here when it is 19 voltage. Then this one receives the signal, the voltage has arrived. Now that 19 is stepped down to about 12 or 11 or 8, depending on the how much is in the battery. And then that voltage now is sent through this inductor, through there to the other side, to this MOSFET, this high side MOSFET. I know, we have the two, you have, instead of using the two MOSFETs here, sometimes they do use one. That is the dual MOSFET this side, and then they use the dual MOSFET the other side. This is the high side MOSFET, which is connecting the main power, that's 19, and then it's switching it, yeah. And that is the low side MOSFET. The low side MOSFET connects to the ground because it also acts like it does the work of a capacitor. It checks or it filters excess power or excess current. Then from there, the voltages enters here, then regulated by this inductor, sent through here. We also have low side MOSFET and high side MOSFET. The high side MOSFET receives the 12 from this inductor and then it sends through this positive side. And then from here, the voltage is sent through this resistor, and then the resistor what releases the power into the main motherboard. That you have this other capacity, this MOSFET. Yeah, this MOSFET is also receiving power from the battery. In case you don't have the power coming from the adapters, the power is brought in through this MOSFET, and then it is sent through this resistor, and then to the motherboard, to the main motherboard. I don't know whether these things are understandable or I'm just making noise. Yeah. Yeah, let me hope I'm not making noise because it will be bad. It will be so bad for all of us because I'll be making noise. Yeah, I'm wasting time, and also I'll be making noise to you, which makes you uncomfortable. So same case with this. So you saw. So the input from the inductors, which let me show you. So we said you have first MOSFET for another line. So let's say this line, the input power for this is this other wing. This fuse, first MOSFET, second MOSFET, inductor. Then it meets along this line to the current source resistor. If you're using another port, if you're using this port, it also enters with your MOSFET fuse, MOSFET 1, MOSFET 2, inductor, then current source resistor. Then from there, this current source resistor receives power from the port, that is 19 voltage, and then it sends that voltage through here. And then from here, this is now the dual MOSFET. This is 2-in-1 MOSFET. Then from here, the voltage enters here. The same voltage which enters is 19. It is switched by this charging IC. From 19, it is stepped down to about 12 or 10. And then through this inductor which regulates that voltage, it sent it through here. And then from here, it is released to the main motherboard. Then along the main motherboard, you will have now other input voltages or other input lines. We have other circuits like this one, this one, this one. So this is a circuit which is represented by the IC and an inductor. Of course, we also have the capacitors. So the input power comes through here. It enters here when it is the voltage which is being released from here, maybe 10 voltage. And then it is stepped down from 10 to about 1 or 0.9 or 1.1, depending on how much is needed by this line. And then that voltage is sent to the CPU if it is going to the CPU. Same case applies to the other step down lines. If the voltage enters here when it is 19, it enters here, and then it is switched by this MOSFET to maybe 3.3 to the other side. That 3.3 is sent through this inductor, then regulated by this, then released here, and then it is sent to the respective location where it is needed. And those applies to every circuit within the motherboard. For example, this one, you have the main power coming in, if it is 12 voltage coming in, this IC step down that voltage to maybe 1.5 or 1.8, and then through this inductor, it is regulated. Then from here, it is sent to where? This one, I believe, this one is going into the RAM. If it is, this is PC4, so meaning the voltage output here is 1.2. Regulated, that the same 1.2 is sent to the RAM. And all those process happens among all of these motherboards here. All of these motherboards have the same issue. For example, this one, the main power which was generated here, if it is 10 voltage, then 10 voltage is the voltage which will be supplied along all these main power lanes uh, within the motherboard. Then if you have that 10 voltage coming here, so you will have 10 voltages here. This is the test point. That 10 voltage enters through this IC, and then it is stepped down from 10 to maybe 1.8, depending on how much these circuits need. We also have the controller, which do what's called the power sequencing, which allocates the voltages to each and every component. It knows that component needs this amount of voltage. So, and that line, maybe this is the line for this card. So that power management chip also knows this line needs like 1 voltage. So it will step down 10 to 1, and then that 1 is sent to the respective line where it is needed. And that IC is what's called the EC, or the SIO, system input output. It has so many names. It's also called the mini computer because it manages power within the motherboard. And that IC is not any other, but this big guy here. This is the headboard or the headmaster. I don't know, or the president of power within the motherboard. Because without this one, even the charging IC cannot operate. Why? Because it is the responsibility of this one to ensure that this IC is enabled. If this is the power IC, it is now the responsibility of this one to allow this one to enable to switch power from one point to the other. The same IC, you see, we have the other monolithic drivers here for power. So the same this IC also is also responsible for ensuring this IC are enabled. So every IC, every power IC within the motherboard depends on this IC to enable those lines. And you have several. So we have like maybe to mention few of these ICs, we have what's called INI. As you can see, this one it is written INI. So this is one of the SIO. We also have what's called ITE. I believe you've seen it before. I don't know which one is this one. Yes, I also have another one here. You see this? This one also I removed recently because it was shorted because I replaced it in another motherboard. This one is called the new button. Yes, this one is new button. You can see it is written there on top. It is written there, new button. You also have what's called what? SMSC. And then our guys, Lenovo's also have their own. They do have their own for Lenovo's. Yes, the Lenovo also have Lenovo. I don't know whether this one I don't know whether this one is having the Lenovo. This one is having their own called Think Engine Lenovo. Yes, even this one is having the Lenovo. Now, there's something I want to add about these SMSCs, these SIOs. So this one, it doesn't control the power directly, but it controls the power by sending out the signals, just enabling signals. I want you to have that in mind. It is not controlling power by sending the power itself. No, it sends the enabling signals to these power management chips. And these power management chips, these smaller chips, this one, I believe you heard when I say monolithic drivers. They are also called BD controllers. BD controllers are power delivery controllers because they do deliver power. They do deliver power. Yes, it delivers power from the main line then to the step down voltage which is needed. Another name for these BD controllers are also called. They also call what? I just forget. Oh, it's called DC-DC converters. They're called DC-DC converters because they do convert a DC voltage to another DC voltage. That is, if it is 10 voltage, that is the DC, to maybe 1.2, which is also the DC. Now, where are we? So, as I was saying, the most common failures which normally happens is these charging ICs, they do fail. Yes. Another thing are these MOSFETs. These MOSFETs also do fail, which is very common. Then we also have the capacitors along the main power lines. All the capacitors along the main power lines are subject to failure, subject to blown up, to shorts. Why? Because they do handle the main line. These capacitors. May the Lord have mercy on them. Yes, let me just show you. Let me show you. As you can see, this is the input. So these are the controllers for power. So the voltage enters into this capacitor. As you can see, even the other one here got blown up. Yes, there was a capacitor or the inductor which was here, which got blown up. So because they do handle 19, so maybe yes, the 19 is coming through this line. Before it enters into this IC, these capacitors are the one responsible for ensuring that that voltage through that line is steady. That is why they do fail, because they are handling a lot of current, a lot of power. Then after here, now the voltage has been stepped down from 19 to maybe 1. Now if you can compare the level of distractions between 19 voltage and 1 voltage, which one is more destructive in case it is having a problem? Of course, it is 19. That is why all the capacitors along the main power line, most of them, they do fail, always. Yes, almost like over 90% of the shorts in the motherboard are all about the capacitors and the PD controller. Why? Because those guys are specialized in handling a lot of power. That is 19 voltage, handling the voltage coming along the main power line. So that was all about the main power line. We also have what's called the always on voltages. Now, the always on voltages are the voltages which must be there for you to say your motherboard has power. You must have the main power line, that is 19. You must have the three always on voltages. The three always on voltages are 5.0 or 5.1 sometimes, 3.3, which is also called the always on voltage, and then we also need to have the 1.8 voltage. So those four types of voltages: the main power, the 5.0, 5.0, 3.3, and 1.8. All those four types of voltages must be there for you to say your laptop has power. In case one of those is not present, let's say you have 19, you have 5.0, you don't have 3.3, and you have 1.8. That case is also treated as no power, because there is no 3.3 always. The always on voltages also are called the FIRAC. They are called the FIRAC, or they are called the LDO. They are also called the LDO voltages. So those voltages, it's not a must that you understand the exact locations, because the location for the LDO voltages always vary. You might find today it is here, tomorrow is the other side, and maybe I'll just give you an hint. I'll just give you a hint where on what to check, or where to see. Among these inductors, as you can see, this inductor on top, they are written some values, their numbers. This one is written 2R2852, R68901, R47, R15, R15C, 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 R68, R68, 1R5. So among these inductors, you will have the inductors which are labeled the same. For example, this one is labeled R68. Here is also another one, R6, and the numbers are the same, R68901, R68901. And then we also have this one, R68901. Now, the three of them are labeled together. So they could be our suspects. Maybe maybe these ones are the 3.3, 5.0, and then 1.8. However, I know this one supplies power to the sound bridge. This one, the way you will understand them, because you'll find that it is having the resistance from the CPU now. So, but anyway, we will just have them like our suspects. Maybe they are the one maybe they are the one which is supplying power to the 3.3 line. And then we also have this one, 1R5 903, 1R5 903. And then we don't have another. So I have two 1R5s. So that one automatically falls into what? We normally call it the family of 3 and 5. Yes, the family of 3 and 5, they always have the same inductor. So that's a trick which we normally use. You find that the always on voltages have the same inductor. 1R5, 1R5, they're the same. Let us also use this one. Can you see this? This other inductor, we test this inductor, 1R5, 1R5. This one is R15, just R15. This one is R15644, R15644. This one is R68, 4R7, R47, R68, 2R2. Right now, the partners or the components which I found is this one, R68, R68, where is it? This one, R68, and then we have also R68. You saw the R68 are three number. Then I have 1R5 and 1R5, two. So it means these are the family. Yes, of course. So I have a family here of R68, R68, R68. And then I have also a family here, 1R5, 1R5. Those are two families. And then I have also another family here, R15, R15. And I do not have another. So this is R15644, R15644. This is just R15, which also send power to the CPU. So these R15s are the one which are sending power to the CPU. This R15 to the CPU. This one R68, I don't know where it's sending power to, but they are three in number. So, and this one, this last one also send power to the CPU. So it means they are related. So meaning both all of them are sending powers. So to where? To the CPU. However, I have 4R7 here, but I do not have the family of that. So that one I rule out. R15, of course, I know that one is going here. R47, same. But here, 1R5, 1R5, these are the family. So it means these are, if this is the 3.3, the other one will be 5.0. If this is 5.0, the other one is 3.3. Out of your experiences, you will now know if this is the line of 3.3 or the other one is the line of 5.0. You will know out of your experience. But bottom line, you must find those voltages. If you are testing the voltages, you plug in the power, check the main line whether it is present. Then from there, you check for 3.3 from anywhere of these inductors. But you pay attention to the inductors which are the same. You look for inductors which are have the same values or the same codings. The discussion has been so lengthy. Let me trust that at least you understood something. Yes, let me trust that at least you understood something out of the discussion, so that you make the use of it. Whenever you have an issue of no power, at least you'll know which are the components you have to focus on, because each and every component, not each and every component is responsible for power supply. So you cannot just randomly check the components which you don't even understand. These components, that's what. This component, that's what. Yes, the main reason why we are discussing this so that we get to understand the components which are responsible for power supply, the power input, the step down lines are which ones. So that whenever you are missing voltage in a certain line, at least you know the component which is supposed to be responsible for sending power through this area is this one. Now there is no power going through this line. Why? Then you have to consider now if it is the input line, maybe MOSFET 1, MOSFET 2. You have to check the MOSFET itself, the main board, whether it is shorted, the charging IC, the intersil, the BQ. Yes, and these ICs are labeled. Are labeled. However, for the interseals, you need to be very cautious and keen, because as you can see, with this motherboard, I have two interseals. I have this interseal, and then I have another interseal here. So these two interseals, we allow, how do you separate them? The interseal which is responsible for power, it must have an inductor, a big inductor somewhere, and then it has the MOSFET. This other one doesn't have any output inductor, doesn't have the MOSFETs. Meaning what? This is not the main interseal which we are supposed to have, so that it can because you can see the tiny components around here, but the other side is nothing. So that tells you that's not the interseal for main power. The interseal for main power is this one. which controls this MOSFET, and then big inductor. And then we also have what? We also have the SIO, Newton, the prefix for power supply. Another component also which might be responsible for power supply is the BIOS. The BIOS is also responsible for power, not directly, just like this one, not directly power supply component, but it also sends out the enabling signals to that. It also sends out the enabling signals to the power ICs. So sometimes we have a laptop which is not powering on, or which is not initiating the powering on of the CPU, because if the BIOS is corrupt, you might find that that BIOS is not able to enable these drivers to switch the power to be used in the CPU. And in that case, you will find that the laptop seems to be powering on, the fan spinning, but the CPU is too cold because there is no power which has been enabled to power on the CPU. And that also is very common. That's why sometimes you find your laptop running the fan spinning, but the CPU, when you touch the CPU, it is too cold. Why? Because the components which are supposed to enable this monolithic driver are not enabling them. That's why those drivers are not switching any power to the CPU. And the solution for that is to program the BIOS. So right now, after discussing all these components that are responsible for power supply, at least you'll have to do something when concerning the laptop with not power. Even if it means you will get stuck somewhere, but at least you'll be able to do some 1 2 1 2. You'll be able to diagnose. You'll be able to confirm indeed the power port released power to the power inductor or the power fuse. You'll be able to determine that the voltage reached MOSFET 1 and it was not switched to the other side of MOSFET 1, or it never went past current sense resistor. You will be able to at least check physically the charging IC, whether it is corroded, whether there's some blown up component around there. You will be able also to test this MOSFET. You know, sometimes this MOSFET also gets shorted, and then you find that they are not able to switch any voltage because they are shorted themselves. So sometimes you find the voltage going in here and it is not going to the other side. And in that case, if you test those components clearly, you will find that maybe this MOSFET is shorted. The low side from the out is shorted, or the low side from the input is shorted, or the same I side from the input is shorted, or the I side from the output is shorted. So you should also be able to know how to test for those MOSFETs whether they are shorted or not. Because again, if you don't know how to test them again, I don't know how you will fix that motherboard. Because you must know how to test the faulty components and the good components. So that whenever you find something fishy, whenever you find a problem somewhere, you should be able to test and confirm indeed this laptop is not able to switch this power because of this component and that component. Then from there now, it will be easier for you to fix that motherboard because you know exactly which component to fix. If not, you'll end up replacing each and every component within the motherboard, and I don't know whether you'll be successful. I am sure you'll end up fucking up everything because instead of fixing it now, you're now demolishing it, even the working components. You're removing them, you're soldering them back wrongly without knowing the direction, without checking the direction, and at that time you'll know you are in deep shit. Same case with the charging problems. The same charging for a laptop to charge. All these input power supply components, all these components that are responsible for input power, they must work or they must be working perfectly for your laptop to charge. Because without the input power from the adapter, your laptop cannot charge. Your laptop is not able to charge your battery because there is no input power from the adapter. And again, the laptop cannot charge itself with a battery. It must rely on the charger. That's why it's called the charger. The power adapter is called the charger because that's the one which should supply power to the motherboard. Yes. I also discussed about the input, the charging circuit in my other videos. I don't know which video, but there's a video also which I talked about the input diagram, just input power supply, yes, input power supply components or diagram. I want you to go and check that video, the input power supply diagram. That input power supply diagram explains everything what I just discussed. That's why I don't want to go back there because I explain in that diagram. I explain everything. What happens when you plug in the power? What happens before the voltage reaches the main power lane? What really happens from the power port, MOSFET 1, MOSFET 2, Jajang IC, all those, the SIO, because also I mentioned about the SIO and what it does. So guys, Let me trust your cutting interest to learn about this motherboard. The good thing about what we are discussing right now is that this knowledge cut across all the motherboards. It is not specifically for the HP or for the Lenovo. When you have a Dell motherboard, ASUS, Acer, whichever the motherboard you have, all the factors, whatever it does, it is the same. The input power supply components, it must have MOSFET 1, MOSFET 2, current resistor, charging IC, the power port. It must have those. The SIO, that is the EC chip, the EC IC. And it cuts across all of them. So once you understand one of these motherboards, you'll be able to fix other motherboards because you'll check those components one by one. And maybe a piece of advice. Whenever you're handling this motherboard, make sure you're cool. You don't have pressure in your brain, in your mind. Because if you do have other things your brain is thinking of, you will not, might not be able to focus enough, and you might end up misdiagnosing. And I always say, if you misdiagnose a lot, that's bad news for you and that laptop. Have you ever found yourself, or have you ever heard of a doctor misdiagnosing a patient? If you've ever heard of it, I know you know the outcomes. The outcomes always patients dies or something beyond something far worse happens. Same case with the motherboards. You know, as a technician, you're like a doctor. You're like a doctor. So meaning you should not make a mistake because if you do misdiagnose the motherboard, you'll end up treating a wrong disease. And then in that case, instead of now repairing that motherboard, you will be destroying it. You will be killing it. And then when you take it to another technician, maybe you get stuck and then you decide to look for someone else who might be able to help you. That person will have hard time because you will have to rectify the problem before now fixing the real issue. Yes. And that is what you normally encounter as a technician. I know even you yourself at where you are. If you receive a motherboard from another technician, we normally have hard time fixing it because first we will have to do what? First we will have to try and correct the problem, and then from there we'll have to go back now and fix the real issue, which is tiresome, time consuming. Yeah, yeah, it's not always good. So I believe you saw how these components works, how they to switch power from one point to the other. We do have other components which are responsible for power supply. For example, this one, I can believe you see this shiny ICs here. These ICs, I normally encounter them, and most of the time when I find them having issues, you'll find them they're not able to get soldered back. These ICs, most of them, out of my experience, or what I've found out about these ICs, especially with the dragonflies and things like the N30 G3 G4. These ICs are the one which supplies power to the speakers. So sometimes if these ICs are shorted, if you remove them, if you remove them, the speakers will not be able, you can see, yeah, I have the speakers, the two speakers. So the two chips are for this one and the other two chips are for this connector. So whenever you have these chips getting shorted, you can eliminate them, just remove them. If you're not able to put them back, meaning that that motherboard will be what? Will not be able to have any sound, but you'll be able to use the external because the speakers are not working because of those ICs. Or sometimes you'll have to use the earphone. Yeah, those are some of the things which normally happens. They are called compromises. Yes, sometimes a laptop is brought to you to fix the issue to do with the screen or bus problem, and then at the end of it, you find that maybe something happens. Or in that case, for example, this issue to do with the speaker, you find that these ICs are damaged and you're not able to get the replacement, the spare part. Then you'll have to compromise. You'll have to tell the customer now, this laptop is compromised. Yes, it's not working, but you'll not be able to have some until you get the replacement IC. So, having said that, I don't think I have any other issue to add on it. Now, some other motherboards, yeah, maybe to finish up. Some other motherboards, you can see this having an inductor and the two MOSFETs. So instead of using the two MOSFETs, some motherboards can use an IC here. instead of this. So if you see an IC, that driver is also doing the work of the two MOSFETs. Instead of two MOSFETs or the dual MOSFET, they place there an IC. For example, as you can see, let us use this other motherboard. In our case here, as you can see, the input for this line, you have an IC and then an inductor. So instead of this driver, this IC, you'll have the two MOSFETs here, which receive the power coming in, step it down, and then send it through this inductor. Same case applies to this one. Instead of using this IC, this PD controller, they also put the two MOSFETs there to switch that power and then send through the output. So always these inductors are the outputs. To have the power coming in through this IC, and then the output is this inductor, whereby it regulates that voltage and then it sends it directly to the destination where it is needed. Yes. Thank you so much, guys. I believe you're able to understand something. You're able to understand something. I appreciate. If you haven't subscribed, still I am asking you, please subscribe, guys. Let us grow this channel together. I really, really appreciate your presence, your patience, and your support. Please subscribe, give us some comments, and in case you are having an issue with your laptop, please do not hesitate to send it to us so that we can fix for you. Or in case also you want to learn about laptop repairs, we also do offer what? We also offer the teaching. We teach laptop repairs. We also do we teach both online and physical. So whichever the module you're interested in joining, you can join it. You just contact me. The contact are in my bio profile. You can contact me. We talk. We see how we can incorporate you into our classes. The course takes 3 months, and it is about the theory sessions, which normally take like 4 to 5 weeks, and then the rest of the days is all about the practicals. Because in this field, without the practicals, I don't know whether you will survive. Because the major area, the major work we do is all about the practicals. Yes, that is the major things we do. It's all about the practicals. That's why we do rush the topics for the theory. Then the practical session is taking long time, because we need to show you how to measure those components, how to identify those problems, how to replace those components, whichever the components we have, if it is a small resistor, ICs, the pods, the MOSFETs, how to program BIOS, how to do the BIOS editing, all of those. And then you also have the basic software teachings like Windows installations, drivers updates, BIOS programming, and all those other software basic ideas you need to know. Thank you so much. Please don't forget to subscribe, and see you in the next video. Goodbye.